In our previous session, while exploring the safe fourth principle, build incrementally with fast integrated learning cycles, we learned that leaving integration to the end make things worse and is one of the main causes of project and product development delays. In this session, let's explore the solution. A more effective approach starts by setting up a structured way to speed up our learning process. This method is based on the plan, do, check and adjust PDCA cycle, which was first introduced by Schuhart and later developed by Deming. The PDCA cycle is a tool that allows us to get feedback quickly and manage the unpredictability of developing solutions. Think of it as a way to apply the scientific method. You form a hypothesis, conduct experiments, and then evaluate the results to deal with uncertainty and gain new knowledge. It's like a continuous loop. Regardless of the outcomes, every experiment provides us with fresh insights that help shape the next hypothesis and lead to more learning or resolving uncertainty. Getting feedback quickly speeds up how fast we learn. When we have shorter PDCA cycles, it means there's less time between doing something and seeing the results. This helps us learn better because we can quickly figure out what works and what doesn't, and it's cheaper because we can stop doing things that don't work sooner. In simple terms, shorter cycles mean faster learning. And to make cycles shorter, we can use smaller batches and modern automated tools for development. Integration points reduce risk. Integration points play a crucial role in risk reduction. When there are no integration points, it can create a false sense of security, making us think that everything is going well when, in reality, hidden problems are waiting to surface later. This is what Oosterwolde calls false positive feasibility, where we believe the plan will work as intended, but it won't. Lean principles offer a different approach. Instead of locking into a single plan too early, we consider a range of options while building the solution incrementally and quickly. Each step gives us a piece of a working system that can be tested and integrated. We keep building on these steps until the solution is complete. Integration points are not just for technical viability, they also help us test the market, validate usability, and get feedback from customers. If needed, they allow us to change direction to better serve our customers. Integration points needs to be deliberate. Integration points are deliberately built into the development process and solution design. They serve as planned moments where different parts of the solution come together, like pieces of a puzzle. Even though each integration point focuses on a specific part of the overall plan, it helps synchronize everyone involved. This regular teamwork ensures that the evolving solution meets the real and current business needs rather than just relying on initial assumptions. These integration points are valuable because they help turn uncertainty into knowledge. They tell us whether the current design works technically and if the solution is sustainable based on objective measures. In their early lean days, Harley-Davidson looked at why some projects failed and some succeeded. Their first inclination was to look at phase gates, but they found there was no correlation between phase gates and project success. After examining a number of factors, the thing they found that correlated with project success was purchase orders. They found that successful projects had many purchase orders spread throughout the project. Unsuccessful projects had quite a few purchase orders at the beginning and at the end, but not many in between. This was because the projects in which the purchase orders were spread throughout the project were having short integration cycles and were ordering the parts at each integration point. The more often we have these integration points, the quicker we learn. In complex systems development, we use smaller integration points within each part of the system to make sure they're doing their job as part of the bigger plan. Then, we integrate these smaller parts into larger parts of the system as we go up the hierarchy. Designers know that the top-level integration point, which happens less often, is the most important for measuring progress. They try to have these points more frequently. Everyone involved understands that if these points are delayed, it's a sign of trouble. But even if there are delays, this understanding helps us make changes to the project scope, technical approach, cost, or delivery schedule to get things back on track. Conclusion: here are some of the benefits of building incrementally with fast, integrated learning cycles. Increased visibility and transparency. By working in small increments, it is easier to track progress and identify potential problems early on. Reduced risk. By getting feedback from stakeholders early and often, teams can reduce the risk of delivering a product that does not meet the needs of the customer. Increased agility. By being able to adapt to change quickly, teams can stay ahead of the competition. It is a simple but powerful way to deliver better products to your customers faster.
Advance Agility is a rapidly expanding global company specializing in digital and agile transformation. As a gold partner of Scaled Agile, we are dedicated to helping organizations implement digital practices and cultivate an agile mindset. For further information and to explore how we can support your organizational goals and personal career growth through coaching, mentoring, and training, please connect with us on LinkedIn and visit our website at advanceagility.com. By using our coupon code MARK20, you can get amazing discounts.